All right, welcome back to day 2 of the unit, the 8th unit. This unit is only 3 days long, so for some of you, 2 out of those 3 days will be via video. So when I get back next week, it will be critical that you come in and ask questions if you have them, because all we have is 8.3 left before we start reviewing and testing. So, and then this is the last test that will go on quarter 3's grade. And the quarter cutoff is March 10th. My March is crazy busy in my personal life. I have birthdays, I have birthday parties, I have baptisms, I have all sorts of things going on with my family. And although I care very much about all of you, they are my number one. And so I have to keep strong to my quarter cutoff date this time. If you bring it to me on March 11th, I will smile at you sweetly and I will say, I'm sorry, I can't accept it. So with that being said, let's move on to 8.2. 8.2 is a little bit longer than 8.1. We're talking about pyramids and cones and spheres. And then we have one more idea to tag onto this. So let's recall what the volume is for a prism. If I'm looking for just the basic volume formula, I have to take the base area and multiply it by the height of the prism. Again, B stands for area of the base, or base area. H is the height of the prism. So this H has nothing to do with the base itself. Now, I have an easier time drawing cylinders and cones than I do pyramids and prisms, but they're pretty much the same thing. So if I have a prism, it looks something like this, right? Where you've got that base. If I have a pyramid, let's see how good I can do drawing this. That's what it looks like. So we've got a pyramid and I have a base. What are their similarities? Well, they both have a base. They both have a base shape. They both have a height. What are some differences? One of the two figures has 2 base shapes. So prisms have 2 bases. Pyramids have 1, and the sides are made at a point, right? At 1 point, right here. Now, I'm going to back this up just a little bit because I can't read the full sentence. If I have a prism, so again, I'll just do a cylinder. If I have a prism and I were to stick a cone inside that had the same base, back up a little bit. If it had the same base and it had the same height, so pretend like that was my cone, how many times bigger do you think the volume of the prism is compared to the cone or the pyramid? So I want you to guess right here. How many times bigger do you think one is than the other? Say it out loud. Do you think it's 2 times bigger? 3? 17? It's not 17. I have this video right here because it's, again, hard for me to show you since I'm not in the flesh. But I have this video right here that, Control-click to follow link, hopefully will explain it to you. It's not very long. you have these two. Hold on, I'm pausing it. So you have these two solids. It doesn't look like this one was filled up all the way, but I promise they marked it so it's right. These two solids, one's a pyramid, one's a square. They have the same base shape. This one's a square base, this one's a square pyramid. They have the same height. I don't think that it showed you that. I had a different video that showed you that they have the same base, the same height, but it was kind of a longer video and it was a little bit more boring. But these two, if I were to put the pyramid inside of the cube, it should fit perfectly. Okay, keep going. Okay, so what can you say? I don't know what he's doing now. Making it look, oh, I don't want to start it again. Okay, so what can we say? What am I doing? Hold on. If I have one right inside the other, it is 3 times bigger. So that means the volume is going to be a third of the size of the pyramid. Can we use this idea to rewrite the volume formulas for pyramids and cones? Let's do that. So, that's pretty. The formula for a triangular pyramid is going to be very similar as the triangular prism. So the volume equals, leave a little bit of space, the base area, which is 1/2 pi, nope, that's not it. 1/2 length times width times the height of the prism. It's going to be a third of that. If we were to write just the generic formula up on top, which there's not a whole room, the volume for a pyramid is 1/3 times the base area times the height of the pyramid. If I say prism, it's because I just spent a half hour making the prism video, so bear with me. Now, if I wanted to, it's not necessary, but if you wanted to, you could rewrite that as 1/6 times the length times the width times the height. This one isn't as crucial because I really want you to remember how you get the formula, not just what the formula is. So this part of the formula is the base area for a triangle. That doesn't look like a triangle. Okay, this right here is the height. This right here is because it's a pyramid. Because it's a pyramid, it's going to have that 1/3 on there. So I would rather you memorize how to get it than what the actual formula is. So let's do it again. Now I've got a square base. The volume is 1/3 because it's a pyramid. Now how do you find the area of this squared? Side times side. 1/3 side squared times h. Okay, let's look at the rectangle down here. It's hard to see. Okay, the formula for the volume is 1/3 because it's a pyramid times the, how do you find the area of a rectangle? Length times width times the height of the pyramid. And then let's look at a cone really quick. The volume of a cone is 1/3 because it's a pyramid. How do you find the area of a cone? Pi r squared h. Now I want to point something out really quick. I'm not a very good shape artist. I haven't done it in a few years, so cut me some slack. If I have a cone And the cone comes up. I want to do this the best I can, like this-ish. Pretend like that worked. Make the line thicker. Okay, whatever. Now I've got several parts of this cone. This right here is the radius. This right here is not the height. That is called the slant height. So we are not using the slant height for the volume of a cone or a pyramid. You have to use the perpendicular height that goes through the middle. That is the height. The same is true if you're talking about a triangular pyramid. So let's have this be the pyramid. If it helps to have these as dashed lines so you can see that it's in the back. Okay, the different parts of this one, pretend like this is your 90 right here. This would be your length. This would be your width. And then, and then whatever this is that comes out of the top, that would be your height. If you have a square pyramid, again, be creative. This is your length, this is your width, this is not your height, it has to come in a perpendicular, that is your height. Okay, so those are your shapes. Let's go back to your notes. Okay, so now I want to practice a few. I think I have 4 again. Find the volume of each of these shapes. Shade the base, name it. So this guy right here, the base, is that. What shape is that? A square, so this is a square pyramid. The formula for the volume, let's find the base area first. The base is a square, so it's 8 times 8, which is 64. So the formula for the volume is 1/3 times the base area times the height. In this case, it is 1/3 times 6 is 2. 2 times 64 is 128 miles cubed. Okay, on your own, try part B. You have 1 minute. Please work with the people sitting around you to ask questions. Okay, so this next one is a cone. So before we start, I've got a cone. This is the base. The radius is 10. So to find the area of the base, it's pi r squared. 10 squared is 100, so it's going to be 100 pi. If I want to find the volume, it's 1/3 times the base area times the height. We're going to have to use a calculator on this one. Where did I put it? Right there. If you don't know how to plug 1/3 into your calculator, this is what it would look like. 1/3, 1 divided by 3, times pi oh, times 100 pi, right? Ah, what am I doing? Pi times the height, I don't remember what it was. 2094.4. All right, next one. The base shape is a rectangle, so this is a rectangular pyramid. Did I put pyramid on those last ones, or did I put prism? Let's see. Pyramid, okay, good. So rectangular pyramid. The base area, the base of a rectangle is just length times width. So you get 6. The formula for the volume is going to be 1/3 times the base area times the height, in this case is 3. So your volume, those actually cancel. Your volume is 6 miles cubed. That's big. All right, on your own, try part D. Try part D, compare with the person sitting next to you. Okay, so the base shape on this one is a triangle. To find the area of a triangle, it's 1/2 times your length times your width. So 1/2 times 8 times 6 would be, 4 times 6 is 24. If I want to find the volume is 1/3, because it always is, times the base area times the height. So 1/3 of 24 is 8. 8 times 9 is 72 feet cubed. All right, go ahead and pause the recording. Maybe take the next 8 minutes or so. I'm not sure what time we're at. I should have kept a timer. Take about 8 minutes or so, work on the first 12 questions on this assignment, and then we'll move on. Oh wait, pause. It's possible you already paused this. Those first 12 questions may have sphere questions on there, so let's just keep going and then you can pause it. We don't have to figure out the formula for a sphere. We could, we're not going to. Google it, I guess, if you really want to know. You also will have to have this memorized though. So the volume for the sphere is 4/3 pi r cubed. Again, they have that cubed because it's a 3-dimensional figure. Make sure you're looking for radius. So in this case, our radius is 3. So our volume is 4/3 pi 3 cubed. Let me show you how to plug that into the calculator. So 4/3 times pi times 3, and then the button to get an exponent is this little caret button right here, or yours might have y to the x, but hopefully you know it by now. 4/3 pi r cubed gives us 113.1. 113.1 centimeters cubed. On part B, this gives us the entire diameter, and the diameter compared to the radius is twice as big. So if I want my radius, divide that by 2. R is 6.3. So plug this guy in. Volume equals 4/3 pi times 6.3 cubed. And you get 1,047.4 feet cubed. Okay, now pause it and maybe take 8 minutes or a little bit less and work on your homework. All right, just like before, we need practice solving these these equations, these formulas in terms of different variables. So if I want to solve the cone formula for r, we first have to remember what the cone formula is. The cone is 1/3 pi r squared h, and I want to get the r all by itself. Oops. So first I'm going to cancel the 1/3. Dividing by, or multiplying by 1/3, what would I have to multiply each side by in order to cancel that divide 3 right here? Multiply 3. So that multiply 3 and that 1/3 would cancel, and you have 3v equals pi r squared h. Now I want to cancel that pi and that h. So these are all connected by a multiply. So let's divide both sides by pi h. The pi's cancel, the h's cancel. So r squared equals 3v over pi h. And maybe put those in parentheses. The last step is to get rid of the r squared. So you cancel the squared by taking the square root. It's kind of ugly. R equals the square root, again we do not need plus or minus, of 3v over pi h. Woo! Let me rewrite that a little bit neater. Pi h. Put parentheses around it. And this is my final answer. Okay, let's look at the next one, part B. Solve the square pyramid formula for S. So the volume of the square pyramid is 1/3. The base area is S squared times the height of the pyramid. And I want S to be alone. More square roots. So we cancel off the 1/3 by multiplying both sides by 3. The 1/3 and the 3 will cancel, so you get 3v equals s squared h. Now I have to cancel off that multiply h, so what do? Divide it. So s squared, I'm going to write that a little bit higher. S squared equals 3v over h. Now I'm going to take the square root of s. And now when I take the square root, please make sure this entire fraction is in the square root. If it's not, then it's partially wrong. S equals the square root of 3v over h. Any questions on that? I'm going to pause for just a minute. Go ahead and try part C. But if you are unsure of A or B, get with the people around you. Have them help you figure it out. Okay. So let's try part C. Solve the triangular pyramid formula for W. So the triangular pyramid formula, volume equals, what do we say up there? We've got 1/3, but because it was triangle, we're going to say 1/6 times the length times the width times the height. And I want to get pyramid formula for W by itself. So let's start by multiplying both sides by, I'm going to try to cancel that 1/6. This is like saying divide 6, so let's multiply 6. So I've got 6V equals L times W times H. They're all connected by a multiply, so let's divide by LH. The L's cancel, the H's cancel, so width equals 6V over LH. I do my L's kind of cursive-y, I'm sure you've noticed, because I don't want them to get confused as ones. Okay, last one, solve the sphere formula for R. Well, sphere is volume equals 4/3 pi R cubed. We want R to be by itself. Now the first thing I would look at is getting rid of that 4/3. It's a little bit trickier, but you can multiply by the reciprocal, which I know you've heard that word before, 3/4. The 3's will cancel, the 4's will cancel, and you have 3V over 4 equals pi R cubed. Here's something very tricky. Go ahead and put your pencils down and just watch for a minute. When I divide this by pi, this is very, or can be very confusing on where this pi should go. This is a divide 4, right? So if I'm dividing 4 and I'm dividing by pi, this divide can kind of sneak in right here. So on the right, I would just have r cubed. On the left, I would have 3v over 4 pi. And now we just have to get rid of the cubed. If you have a squared and the square root cancels it, what do you suppose will cancel a cube? That's a cube root. This little 3 right here will indicate that it's a cube. So I have to take the cube root of both sides. Please make sure the 3 is inside the little arch thing so it's very clear that it's a cube root. Those will cancel, and r equals the cube root of 3v over 4 pi. That is ugly. That's okay. All right, check the time. If you have time to pause it, then please do. If not, then let's just keep going. All right, Cavalari's principle. I'm not going to lie. I don't know that I'd ever really heard of this particular problem before. I actually looked in an old geometry book that I used to teach from, and it was in there. We just never got to it. The concept, however, makes sense to me. So Cavalari's principle is saying that if you have two figures that have the same base area, meaning this area right here and this area right here has to be the same, and the top area is the same. In this case, it's a pyramid, so there is no area, but it could happen with a cone or with a pyramid. No, what am I talking about? It's like, it could happen with a prism or a cylinder. If that's true, and the height is the same, then any cross section, which right here, would have the same area, and the two volumes would be the same. So why is this useful? Let me show you really quick and see if it makes sense to you in a different way. Let me take this out, re-blur it. Look at my pretty table. Okay, now if I have, going back to my stack of papers, if I have this stack of papers, could I calculate the volume of it? It has a length, it has a width, it has a height. Where did I put that? No, different stack of papers, I guess. There we go. It has a length, it has a width, it has a height. I could calculate the volume of this. Now, what would happen if I stagger these papers around? Would it have the same volume? Would it take up space? The same amount of space? The answer to that should be yes, because it's the same stack of papers. Now, will there be more gaps kind of underneath it? Sure. But because it has the same height as originally, it's going to take up the same space. Now, let's look at this again. Look at my set of CDs. This would be considered a cylinder because it's got some width. It's got a circle base. Now, if I take these CDs and shift them, I don't have many CDs, and I don't want to scratch them. If I shift them that way a little bit, is it the same height as before? Should it have the same volume? Well, they're the same CDs, right? It's taking up the same space. Yeah, underneath here there's going to be some space. I'm going to stick these under. There's going to be some space underneath there, but it's taking up the same amount of volume. So that's what Cavalari's principle says. It says that if I have two solids and their height is the same and the base area is the same, then the entire volume will be the same. Now, why does this matter? Sometimes our solids are not all right solids, meaning they're standing up straight, like a can of soup or a box of macaroni. They're sometimes slanted. The process of finding the volume is the same. However, the height may be outside maybe shown outside the figure or the solid. Let me show you what I mean by that. By the way, these were very hard examples to come up with, so I don't have very many, and the picture quality is pretty bad. So right here, this is a cylinder. This is a stack of CDs that have been pushed over a little bit. If you shifted everything this way, so it was standing up straight and tall, it would have the exact same volume as what it has when it's shifted over. I keep showing things with my hands and I forget you can't see. So the process of finding the volume is the same. I need to find the base area. In this case, the base is a circle. So the formula for the volume, or the area of a circle, is pi r squared. In this case, we'll keep it at 16 pi, because 4 squared is 16. The volume formula, now this is a cylinder, so do you need the 1/3? No. Is the base area times the height, which again, the height is shown on the outside, but it's still how tall that stack is. Let's plug this into the calculator. 16 pi times 9 is 452.4 yards cubed. Part B, this guy's been knocked over on its side, so its height is kind of laying up against the ground. The height should be perpendicular to the base, which this one is. So again, a cylinder, so my base area is pi r with r, 7.5 squared I don't know, yeah, 56.25 times pi. If you wanted to put that as a decimal, you could. Volume, do I need the 1/3? No, because it's a cylinder. The volume is the area of the base times the height of the cylinder. In this case, the height is 18. So I get 3,180.9 millimeters cubed. All right, part C. This is a rectangular prism. So again, because it's a prism, you do not need the 1/3. The base area is 2.5 times 3.5, which is 8.75. Volume formula is the base area times the height interesting. You get a whole volume. So 28 feet cubed. Part D is a cone that's kind of tilted on the side. So if I want to find the volume of the cone, the base is a circle. So pi 8.6 squared. The volume, do you need the 1/3 this time? Yes, because it comes down to that point. Volume is 1/3 times the base area times the height. So plug that whole shebang into your calculator. It is critical that you have a calculator for this test. There is no, you could use a dinky little calculator. Very hard to do this by hand and get the answer correct. Very hard to do this with a little dinky calculator and get it correct. Please have a calculator. If you are moving on to secondary 3 next year, 3 or 3 light, you need a graphing calculator. They're not really on sale right now, but you can find them in the stores right now because it's no longer back to school season. You may want to get one. It's worth your time because you will get to know how to use it. Okay, so go ahead and, I think this actually might be the very end. Let me look. Day 3. So that's the end. Hopefully you've had plenty of time to get your homework done. Help each other out. And thanks for watching. Peace out. See you when I get back.